Okay, so welcome back to this tutorial. In the first part of the tutorial, we did the MCQ from the Physics Supplementary Exam from 2015. And in this part of the tutorial, we're going to do the second question, which is on kinematics and vectors. Okay, so let's read the question. Okay, so it says, Tandy drives a motorboat and still water across a dam directly from point A to a jetty at point C. So this is the distance that Tandy drives. Cool stuff. Okay, then Susan walks 240 meters at an average speed of 1.5 meters across the bridge. So that's that section. Okay, and then it says that for the next 100 meters, she does that for the next part of her travels. And then it says that it takes Susan a total time of 3 minutes to get from point A to the jetty at point C. So that is all for Susan. Cool. Let's get into the first question now that we've read everything. Okay, so question 2.1. So first we have to define distance and then state who travels the greater distance. Okay, so what is distance? So distance is a scalar and it's essentially the length of the path traveled, right? So essentially what we have to do is just work out the total length that they travel, taking into consideration that Tandy goes straight from A to C, where Susie goes from A to B and then from B to C. So if we work out the distance for, let's work in black rather, the distance for Tandy, we can see that through Pythagoras, it's just the square root of 240 squared plus 100 squared, which comes to 260 meters. If we look at Susie, the distance for Susie is equal to 240, which is from A to B, plus 100 meters, which is from B to C, which is 340 meters in total. So who travels the greater distance from A to C? The answer is therefore Susie. Susie has, so we can say therefore Susie has the greater distance. Okay, question 2.2. Okay, question 2.2 says we have to define displacement. So what is displacement? So displacement is a vector and it is the change of position. Right, so if we look at displacement, so both Susie and Tandy both start at this point A, and both of them end at point C. So what we can see is that their displacements are both the same. So we can say neither of them have actually traveled, have a greater displacement. So the answer is therefore neither. So in this one it is Susie, in this one it is neither. Okay, question 2.3. Calculate Susie's average speed between B and C. So we're looking for Susie's average speed. So what information are we given? So we're given that T total is equal to 3 minutes, which is equal to 3 times 60 seconds, which is equal to 180 seconds. So that's the total time she takes to do this whole trip from A all the way to C. Okay, now we've been given the velocity, or not the speed rather, we've been given the speed for this section from B to C. So the speed from A to B is equal to 1.5 meters per second. And we also know the distance from A to B is equal to 240 meters. So if we do a simple speed equals distance over time, we can manipulate this to give us time equals distance over speed, which is equal to 240 over 1.5, which gives us the time taken to travel from, so time taken from A to B is equal to 160 seconds. That means that the total time, T total is equal to TAB plus TBC. And therefore, by manipulating this, we can see that T, or the time to travel BC, is equal to 180 minus 160 seconds, which gives us a total time of 20 seconds. So the time it takes Susie to travel this distance here is 20 seconds. And we're looking for the speed. So the speed, or the average speed between B and C is equal to the distance traveled over the time, which is equal to 100 meters over 20 seconds, which gives us a total of 5 meters per second. So that is her average speed. So we've done that question, we've done that question, and we've done that question. Okay, let's move on to 2.4. Okay, so 2.4 says calculate the average speed, calculate Susie's average speed from A to C. So we want to know the total speed for her to travel all of this. So the speed average is going to equal the distance total over the time total. And the total distance that Susie travels is 340 meters. And the total time that she takes is 180 seconds. Which means that her average speed is equal to 1.89 meters per second. Okay, last question, question 2.5. So it says calculate the magnitude and direction. So it's asking for two things, magnitude and direction of Susie's average velocity. So velocity from A to C. So we want to know her velocity from A to C. So velocity, or V, is equal to change in position. From our definition is the change in position, or the displacement. So change in position over the change in time. So what is the change in position for Susie? Her displacement is simply that total distance from A all the way to C, which we calculated to be 260 meters. And the time it took her was 180 seconds. So the magnitude of her velocity is equal to 1.44 meters per second. Now we need to calculate the direction. So let's label this direction theta. And basically we need to calculate that angle theta. So let's start with tan theta equals opposite, which is 100. So opposite over adjacent distances, which is equal to 100 over 240, which gives us a value for theta when we take the inverse tan, -1, is equal to 22.6 degrees. Okay, so that's 22.6 degrees. So what we can say is the final answer is that her magnitude and velocity is going to be 1.44 meters per second, or let's write that as meters per second like that, at 22.6 degrees clockwise. So we're taking that distance there and we're taking the clockwise direction from the bridge. And that would be the final answer. And that's the last question as well. So in the next tutorial, we'll go through this next question. Thanks for watching, guys.